You guys, some of you might be familiar with like the concepts of site-to-site VPN, or maybe you have just made some GRE tunnels and similar things on routers. The concepts are quite similar. Like when you want two branches to be connected with each other, and you want VPN between them, you use site-to-site VPN. Okay. And in fact, if you have any experience of configuring VPN on any router, there you have to define profiles, okay, in which you define encryption algorithms, authentication algorithms, okay, and that is what sometimes people find difficult a little bit, because they sometimes miss a step or forget to define one of those things. Like as a beginner, I'm telling, it's not that difficult to configure it on even a router, but sometimes just because people don't remember all of it, it becomes difficult to configure. Whereas here, if you look at the firewall, they have defined the profiles required for VPN. Okay, and this will be the topology that we will be working on. Okay, and it's very simple. There's this VPC and the VPC, simple PCs. Okay, to check connectivity later between VPC 4 and VPC 5. And here the subnet is 10.0.1.0. Here the subnet is 10.0.2.0. Okay, and this is one of the offices having one public IP here, the other public IP here on ISP. Okay, this router will act as an ISP router. Okay, it's just configured with public IP addresses, two of these IP addresses. Okay, so it doesn't, this router doesn't know about these subnets. Okay, I'll show you that. But before I go into the practical aspect of it, I want to show you something here. Okay. And this management link is just being used to manage the firewalls. Okay, don't think that this is providing any sort of connectivity into the firewall. Okay, so what I want to show you is, like, if you go to network, okay, here you'll find these things called IPsec crypto and IK crypto. Okay, and in router we define these cryptographic profiles manually. Okay, which defines things for IK phase 1, phase 2. And if you see here, this is a fresh firewall. I have not configured anything. Out of the box, they have these IK crypto and IPsec crypto profiles inbuilt onto that. Okay, so you can easily utilize the existing profiles rather than creating manually. Okay, fine. Okay. So, if you talk about the VPN deployments, currently what we are not talking about is Global Protect. Okay, Global Protect is used like if there are mobile users who are moving around on their laptops and mobiles trying to connect to the corporate headquarters. That's Global Protect. We are not going to talk much about this right now. Later. What we are talking about currently is like if you have, you know, a partner or some, some of other offices where you want site-to-site VPN. Okay. Also, it's not necessary
So Danishu,
to have. Yeah.
so what will be the, I mean, the basic difference between site-to-site VPN and global protect for mobile users?
This is using just like when you use any connect VPN client on the end device and connect. It's for a different purposes. It's for end devices, right? Like when you use when you work from home, which VPN client do you use?
Yeah, we use global protect. That's what I'm saying. I mean, it's just like that.
Yeah.
Before that, we
So,
have.
so this is for remote access VPN. Okay. This is not for site to site VPN, right? Because somebody working from home is not a company site, right? There you cannot ask people to install a firewall or a router and establish site to site VPN from their home, right? So that's why remote access VPN is another technology which gets you connected to the headquarter, but it's for individual end device. Okay.
Okay.
For end devices to connect to the corporate network, we have Global Protect. Okay. Now it's not necessary to have Palo Alto firewall everywhere. Someone trying to join the meeting. So what I was telling you is like it's not necessary to have Palo Alto firewall everywhere. You can have a Cisco router and establish a VPN with firewall. Doesn't matter. Okay, it's just that you'll have to define the similar settings on the other side. So the other thing that Palo Alto has available is called they call it LSVPN. It's actually site-to-site VPN, but a quicker form of deploying site-to-site VPN. Okay, and this is what they call LSVPN. Okay, now what is it? Basically, same site-to-site VPN, but if you are having Palo Alto firewall at all your offices, you can have a fairly quicker deployment of VPN between these sites. Okay, like you can generate some configuration and quickly have it synced across these firewalls to establish the VPN connectivity. Okay, so currently let's talk about initially this site-to-site VPN. Okay, so it's a VPN that connects your central site to a remote site, depending upon how you want it. Okay, you can have a hub and spoke topology, you can have a full mesh topology. It depends. Okay, now firewall uses IPsec, IP security, which is a set of protocols so that your communication doesn't get intercepted in midway by anybody. Like it's encrypted. Okay, and the second form that I was talking about was remote user to site VPN. That was remote access VPN as well. Sometimes people call it remote access VPN. This is where people are running the global protect agents and clients into their end devices and establishing again SSL and IPsec VPN between the end device and your corporate site. LSVPN, like I told you, it's a simpler mechanism to roll out site-to-site VPN more easily compared to configuring manually site-to-site VPN. Okay, but for this LSVPN thing, you need to have Palo Alto firewall at all the sites. Okay, which will be involved in this. So let's talk about site-to-site VPN. Okay, and in fact, let me introduce you to the topology here a little bit and make you understand things. See, the subnet here is 10.0.1.0. Okay. Now, what happens is if your VPC4 is trying to suppose communicate with this VPC5, source IP, it will use 10.0.1.1, 1.11, whatever it is, okay. And the destination IP, it is going to use 2.11, okay. Now, see, the problem here is like there is internet in the middle, okay. And even if you send the traffic out on internet for this, it's going to get discarded because this is private IP address traffic. So what you do is, like, I'm just giving you a high level overview, we'll go into the details of it, okay. What you do is you take up this packet, okay, which was generated by this guy. Like what firewall does is, it will take up this packet with all the source IP, destination IP in there and put a new header on it. Now here, the source IP it will use is its external facing interface IP address. In this case, it will be 100.0.0.1. Okay. And the destination IP it's going to use is 200.0.0.1/24. Okay. So this IP address is not checked when the packet is out here on the internet. Everybody looks at this external header and routes it on the internet. And because this is public IP, it's completely routable till the other site and reaches Palo Alto 2. This is where Palo Alto 2 will remove this and send the packet directly to the other device. Okay. Now, I'll just clarify some things. Like this router is being used by as an ISP router, and I want to show you that there's no much configuration here. Okay, there's just IP addresses. Okay. So fastnet 0/0 has an IP, fastnet 0/1 has an IP, and that's it. Fine. So I'll close this. Let's come back here. So a VPN connection allows you to have two local area networks on private IP and connect to it via site-to-site VPN. Now, there are some of the VPN devices are policy-based devices, and some of them are route-based VPN devices. There are two types of devices in the world. Now, in route-based VPN, based on the routing decision, it is decided whether you want it to be going through VPN tunnel or not. Like Palo Alto firewall, when it receives the packet here, it will have either static route or OSPF or some form of route which makes it point to the tunnel interface. Okay, and what is tunnel interface? It is a logical interface between the two sites, because physically they are not connected to each other. Physically they'll be very far away, right? But logically they are connected to each other, and that is what they realize, or that is what they uh, use tunnel interface to communicate with each other. Okay, like logically to show the connection. So what I was telling you here is, like, when the packet received on the firewall is pointed to this subnet on VPN pair B, then VPN pair A will actually see first the route. When it has the route based uh, configuration that 10.0.2.0 subnet is on the VPN tunnel interface, that is when it decides that it needs to forward it through the using VPN. Okay, so route-based VPN is where firewall makes a routing decision based on destination IP, and if traffic is routed to a specific destination through VPN tunnel, then it is handled as VPN traffic. Okay, the other policy-based devices, in those you define a policy in which you define which things you want to use for VPN, which particular uh, type of traffic you should forward to VPN. But most of the devices you will find out there is route-based VPN. Okay, but if in case you want to establish a VPN, a site-to-site VPN with a third-party device, which is policy-based VPN device, you can still configure it, make it work. Okay. Now, about the basic working, I didn't get any Palo Alto, images, so I utilized the one from Cisco. Think of this R1 as Palo Alto firewall. Okay, because the basic concept remains same. So here PC1 is trying to communicate with S1, that's 10.1.2.2. Okay, and when this packet reaches R1, when this original packet reaches R1, R1 looks at the destination. Okay, and finds in the routing table, like I was telling you, that system receives traffic destined for remote private network, looks up the next hop in the routing table. Okay, and in case the routing table points to a logical tunnel interface, okay, then it's going to send the traffic through tunnel. Okay, now what happens here in is it will put the source IP of its public IP and destination IP of the pairs, VPN pairs public IP here, and ignore this GRE, it will be IPsec, and a lot of things will be different, but ignore the physical stuff. Okay, when this packet is out there on the internet, everybody looks at this destination. Nobody looks at the inside payload packet, which originally was like this. Okay, so everybody looks at the public IP and routes it here. When it is received on the second VPN pair, you remove this headers and take out the original payload, and then forward it out to the destination. Okay, so that's how VPN works. Now, IPsec, the job of it is to secure this. Okay, and make it encrypted, okay, because we don't want traffic, private traffic to be sent unencrypted. Now, the IP packet is embedded, like I was telling you, in another IP payload, and a new header is applied through IPsec tunnel. Source IP in the new header, like external header, will be of local VPN pair, and destination will be of the far end of tunnel, like we were discussing. Okay. When packet reaches remote VPN pair, outer header is removed and original packet is sent to its destination. So end devices or end users don't even notice that there was something like this done in the middle. Okay. GRE is one type of IP tunnel that Cisco uses a lot with routers. Okay, that's why you saw GRE here. Okay, now here we are just using IPsec. Now you need to work with matching settings to create a tunnel. Like you will have to have the similar set of settings on one end and the other end of the firewall. Okay. And you could use a routing protocol to exchange routes, or you could exchange routes statically, not exchange, but like you could manually define those routes statically. Okay. Now, when you configure the tunnel address, okay, often at times people don't feel the need of tunnel. People feel like, okay, so what is the tunnel doing? Why do we need tunnel? Okay. See, let's take it up this way. Suppose this is one router and this is another router. Okay. Even if you are trying to connect these R1 and R2, suppose they are in the same office, you would need a wire, right, to connect them with each other. And then you are going to configure an IP address on one end of that wire, right? Another IP address on another end of the wire. Okay. This is what VPN tunnel is doing here, or the tunnel interface is doing here. It's acting as that logical interface which is connecting these two firewalls. Okay. So whenever Palo Alto 1 needs to send traffic to Palo Alto 2, all that traffic will go using the tunnel interface. Or if you have to point static routes, or if you feel like Palo Alto 1, Palo Alto 2, they need to be OSPF neighbors, they'll recognize each other via the tunnel interface IP address. Okay. Now, the tunnel interface address here and here will be from the same subnet, like you can see in this scenario. The tunnel interface IP here is 10.0.3.1, 10.0.3.2. Okay. And the tunnel source, okay, in Cisco, you define the tunnel source and tunnel destination. Okay. So tunnel source here will be this public IP. Okay. Tunnel destination on Palo Alto 1 will be this public IP. And this goes vice versa. When you configure the tunnel source will be this here, and tunnel destination will be this when you configure it on Palo Alto 2. So same thing is shown by this image here. When you define the tunnel source, whatever you use as tunnel source here becomes tunnel destination on the other side. Whatever you use tunnel sources here becomes tunnel destination on. Okay. And these addresses are usually from the unsecured network or public network, usually internet. Okay. Now you need to authenticate the pairs, okay, or the uh, two ends of VPN tunnel. And once they have successful authentication, they negotiate what kind of encryption mechanisms we are going to use to secure the communication. Okay. And for this, they have IKE, which is used to verify whether the other end is really who they say they are or somebody different. Now, one of the easiest ways to identify each other is you can have a pre-shared key, like a password. Think of it as like a password, which is here on Palo Alto 1 and 2, and at both the ends it is same. Okay. The other way you can do it is you can have certificate, but what certificate will require is that these two people should trust a common CA, a common certificate authority, from whom you will get certificates for both these firewalls. Okay. So instead of using the pre-shared key, you use the certificate. Certificate is more secure because not everyone can generate a certificate easily. Like if some potential attacker is trying to do something. But pre-shared key, the only flaw in that is if your network engineer reveals the pre-shared key to somebody, then there could be some consequences in which your device establishes VPN with the wrong party. Okay, so you can use digital certificates or pre-shared key. Okay, and Diffie-Hellman keys are used to set up the security associations for IPsec tunnel. Now, actually, this is a very a very big topic in itself, and most of the times you might have if you have gone through engineering of computer science, IT, sometimes you might have that subject of cryptography which discusses this in lot detail. You don't need all those details here, okay? Because what we are going to do is we are going to use the same Diffie-Hellman group on both ends, okay? So when you combine all these things, okay, when you combine the security protocol, cryptographic keys, destination IP encryption, data authentication, data integrity, uh, like when you define all settings, these settings are called the security parameter index. Okay. Now, for configuration or you know in VPN setup, what these two firewalls will do with each other is suppose this VPN pair A needs to verify and establish the VPN tunnel. A VPN pair A will use IKE crypto profile parameters, okay, to establish a secure connection and authenticate VPN pair B. Okay, what is IKE crypto profile? Just like I showed you in the beginning, you can define these manually. Okay, if you feel like no, this is not sufficient, I need to do it manually, you can define that. Okay, but if you look at this, it defines Diffie-Hellman group, encryption mechanism, authentication mechanism, okay, and some timers and lifetime. Okay, now you have to use the same IKE crypto profile on the other end, or create yourself and have the same settings on it. Okay, fine. This IKE crypto profile basically defines the parameters to establish IKE phase 1, or the phase which is used to secure connection and authenticate whether this party is really who they say they are. Okay. Then once it establishes the initial VPN tunnel, okay, then there is IKE phase 2 parameters, which are used to secure the actual transfer of data between the two sites. For this IKE phase 2, we have the IP script profile. Okay. Now see, here these are the things that you can configure. Okay. Now what you do here is, you know what, let's configure this before we go further. Let's configure parallelly. The configuration steps are mentioned in the slide. Okay. Let's first configure the basic IP addressing. Okay. Ethernet 1/1. That's inside interface. Okay. And here I'll give an IP address. Management profile is not necessary, but just in case we want to troubleshoot it using thing or something, then okay. So that's Ethernet 1/1. Next, let's configure Ethernet 1/2 with the public IP. Okay, that's 100.0.0.1. Okay. Right now, I'm not doing any VPN configuration. Firstly, let me just configure the IP address. Okay. And initially, I'll not go into security policies as well. So what I'm going to do is I'll just override the default policy and make it to allow everything. Okay. Also, let's configure the default route pointing towards the Ethernet 1/2, actually pointing towards the ISP. Okay. The next hop will be 100.0.0.2. I'll go and set a static route. Interface Ethernet 1/2, 100.0.0.2. The next hop IP. Okay. That's it for initial configuration, like basic setup. Then we'll go into.
Don't you have one question?
Yeah,
Can whenever we do a trace route, we can find a firewall in between. Is there any possible way to hide the firewall from trace?
if you don't enable interface manager profile, I don't think it will respond because even for trace route, it sends ICMP. So if you have not kept a management profile on the interface, firewall will not respond. So I don't think it should uh, it should show up.
No, actually, whenever we have to pass any INC, we need to check the trace, and we get all the information regarding the Palo Alto. So, is there any possible way to hide the firewall from the trace?
I'm saying the same thing.
No,
There is no there is no checkbox like hide unhide
okay,
on your interfaces. If you don't have management profile, it's not going to respond to those ping requests.
okay,
Okay. Second, ensure that you don't have those management profiles with respond to ping. Once you don't respond to ping, automatically nobody is going to recognize that your firewall comes in media.
okay.
There is no button like if you are looking for a button hide and hide. No, it works based on this management profile. Like let me set the IP address here as well. 10.0.1.11/24 gateway 10.0.1.1. Okay, let's configure the other firewall. And again, Ethernet 1/1 has an IP of 10.0.2.1. Okay, and here we have 200.0.0.1. Again, let's configure a default route in which we point it to the 200.2 ISP's IP. And again, for initial things, let's go step by step and override it for now. Then I'll come back to security policy and make specific rules. Okay. Now, if you go to the firewall, okay, we can ping and ping host, sorry, here 100.0.0.2. That's ISP. We can ping even 200.0.0.2. Okay, I think we need to mention the source. Source. Okay. Because firewall was trying to utilize some other IP addresses. Okay. So if you are trying to ping from 100.0.0.1 here, if you are using the source of 100.1, trying to ping 200.2, that works as well. And if for the same thing, if I try to ping 200.1, that's this firewall here, I get a response. So public to public connectivity is fine. Okay. We don't have routes for the private till now. Okay. If you see show routing route, we don't have on this firewall a route for 10.0.2.0 subnet. And You can use the show IP route just like that. There is show routing route. Okay. So now what we are going to do is we are going to create a tunnel interface, and in that tunnel interface we are going to point the static route, or we could run OSPF on both the firewalls. That will also work. Okay. So if I go to Palo Alto here, and like I told you, we have this IPsec crypto and IKE crypto already there. Okay. So if you have these, you can directly go and configure a IKE gateway. Okay. And this is where you mention the tunnel source, tunnel destination. I'll click add. I'll show you. Okay. Now this is where you say like, okay, what is my local IP address? This is like the tunnel source. Okay, like Ethernet 1/2. In Cisco, we give in the tunnel interface the tunnel source, tunnel destination. In here, you gave it in IK gate. Okay, and the pair IP address, the other party's IP address, that's 200.0.0.